Welcome back. So let's talk about relative age. We're going to kind of go in the reverse order in which we just talked about ages. So we'll go relative, geologic, absolute. So relative age, as a reminder, is just relating one rock or some sort of formation or fossil to another rock, formation, or fossil. Which one's older, which one's younger. No numbers, no time frames, just relative to one another. So here's an example. I want you to think about this. Here is a bunch of layers of sedimentary rocks. We'll talk about rocks in another unit, but these are just different layers of rocks that have been laid down. So, not a trick question. Oops, let me go back to that. Trick question, which rock layer was laid down first? Do you think it was maybe the rock layers towards the bottom, in the middle, or the rock layer that was on top? Which one was laid down first? Try and give you an example here. Again, not a trick question. One box. Box. 3 boxes. So which box was laid down first? The one on the bottom. All right, so not a trick question. So, as far as this, which rock layer was laid down first? The one at the bottom. So which rock layer is the oldest? The rock layer that's oldest is the one that was there first. The one at the bottom. So right there, you're already relating relative age. You're kind of comparing these layers of rock. So if we're looking at this outcrop of rock that shows us this cross-section of Earth, we can say, oh, you know what? Where are the oldest rocks? Oh, down at the bottom layer. Where are the youngest rocks? Up at the top layer. That's true most times. There's always some weird stuff going on in geology. Sometimes layers get flipped over due to plate tectonics and things crashing together, etc., etc. But normally, oldest rocks are at the bottom, youngest rocks are at top. All right? That's relative age. So that's looking at something called stratigraphy, looking at the stratigraphic sequences, looking at the strata, the layers, to come up with some sort of kind of meaning or history of the Earth in that area. What happened, what occurred to get the Earth and rocks to look the way it did in that area. That's stratigraphy. So in order to kind of really figure out stratigraphy and relative age, you know a handful of things. First, sedimentary rocks. Sedimentary rocks, that's their own unit. We'll talk about that, I think, in like Unit 6 or something like that. But for now, all I need you to know is that sedimentary rocks are little particles and pieces of sand, pebbles, little rocks, little stones, other material that accumulates in kind of horizontal layers, and over a long period of time, it gets compacted and cemented together to harden into rock. That's what sedimentary rocks are, made from sediment. What's sediment? Sediment is pieces of dirt, rocks, pebbles, whatever. You squish it together and cement it together, then it becomes a sedimentary rock. All right? So again, looking at the layers in this outcrop here, where are the oldest rocks? Well, at the bottom. Where are the youngest sedimentary rocks? Up top. Sedimentary rocks are, they form, again, horizontal layers. So if you're seeing horizontal layers like this in rocks, most likely, not always, but most likely you're looking at sedimentary rocks. For instance, the Grand Canyon, made up of a bunch of horizontal layers, sedimentary rocks. Another type of rock is igneous rock. Igneous, come from a Latin term, that Latin root. Think igneous, think ignite, fire. So these are rocks born of fire. So igneous rocks form when liquid hot rock known as magma below ground, or liquid hot rock at the surface known as lava, whether magma or lava, cools, hardens below the Earth's surface or on the Earth's surface, creating a new rock. So when hot molten magma or lava cools to form new rock, that's an igneous rock born of fire. So this is in Yosemite National Park. This is El Capitan, very famous single chunk of igneous rock that very famous for climbing. If you ever saw that movie Free Solo, that's what that gentleman climbed. But this is an example of magma that cooled below ground to form this igneous rock. Well, if the magma cooled below ground to form this rock, and now it's above ground, way up high, how did it get there? That's part of that story. Or sometimes molten material, lava, cools on the surface of the earth, cools, hardens, becomes rock. So igneous rocks that form on the surface, a great example is what you see here. So we have a type of volcano in the background, lava flowed out of it and cooled to create this dark igneous volcanic rock. So where do you think this is? Very volcano-y, almost look like the moon almost, very stark. Most people probably say Hawaii. Nope. It's Flagstaff. It's Flagstaff. There's a bunch of volcanoes in Flagstaff. Most of them are extinct. But yeah, there's a bunch of volcanoes. So yeah, this is Sunset Crater National Monument just outside of Flagstaff. So, again, these rocks tell a story. We're trying to uncover what that story tells us. Also, metamorphic rocks. This is the third type of rock, and that will be Unit 7 or so. Igneous rocks will be Unit 5. So metamorphic rocks, these are rocks formed deep underground where existing rock is changed due to high heat or high pressure. So morph means to change, like the Mighty Morphing Power Rangers. They morphed, changed to the big Charizard or whatever it's called. So metamorphic rocks are existing rocks, either sedimentary rock, igneous rock, or even some other metamorphic rocks. But heat and pressure kind of heats it up a little bit, squishes a little bit, stretches a little bit, and alters the existing rock into a new rock. It doesn't melt all the way, because if it did, it'd now be back in the realm of igneous rock. But if it's just enough heat, just enough pressure to alter it, and then it cools to form a new rock, that would be a metamorphic rock. Metamorphic rocks, you can see a lot of weird squiggles. They're sometimes shiny, sometimes sparkly. But again, they form from existing rock, from heat and or pressure. All right. So additional thing you need to know if you're trying to figure out some stratigraphic sequence is something called an unconformity. In geology, sometimes weird things happen, just like that. Sometimes weird things happen, and those are called unconformities. That's missing rock layers. So a gap in time is missing. There's missing information, known as an unconformity, or some process that's different than what was going on. The processes changed, different types of rocks form under different processes. Something weird happened to make that change. So here's an example of an unconformity. So first off, I want to point out the size of it. You can see a person standing down here. But notice how these layers are kind of like, it almost looks like they're folded up, just kind of folded up layers, very crumpled up. But on top of that, it looks like those folds have just been kind of cut off, and then this layer of rock, horizontal rock, is now on top. So this is weird. So you had some process to fold up these rocks. So in order to fold rocks, you need to squish them together. So some sort of so this bottom part is probably near some sort of convergent boundary. And then all of a sudden you get this flat horizontal layer of, it looks like sedimentary rocks deposited on top. So you had this compressive force, and then all of a sudden there wasn't there anymore. Now you have this sediment kind of being layered on top, turning into rock. That's weird. These are different processes to make these areas look different. That's weird that one would happen after another. This is known as an unconformity. And there's a few different types, which we'll talk about in a little bit. And then finally, we have zones of contact metamorphism. This is where the rock edges, or edges of particular rocks, are burnt and changed by magma. So here is an outcrop of rock. Kind of looks like maybe sedimentary rock, maybe some sort of lighter colored igneous rock. But in any case, you get this dark colored material kind of cutting through. So this is probably some other dark type of another igneous rock. So it's cutting through this layer of other material which already had to exist. In order for this layer of igneous material to cut through another one, that other thing had to be there first. In order for me to jump through a window, the window has to exist first. In order for the Mr. Kool-Aid Man to bust through a wall, the wall has to exist first. Make sense? So in order for this black material to cut through this other stuff had to exist first. So we have this existing rock, and then it looks like this hot magma kind of cut through, eventually cooled and solidified. But when it did, as it was cutting through here, you can see that just above it and just below that black material, you can see this kind of lighter tan pinkish rock, which is what this hill is made out of. It got burnt. It got altered a little bit. It kind of changed. It changed a little bit. It changed color. So this would be an area, a zone of contact metamorphism. This rock, this existing tan rock, changed a little bit. This hot material changed that rock a little bit. So remember, metamorphism is a change of existing rock to something else by high heat and or pressure. So hot magma, as it's cutting through a lot of heat, when coming into contact with existing rocks, it will alter that existing rock a little bit, very near where that hot material is cutting through. And then it looks like this magma cooled, solidified to create this blackish rock here. So again, get some sort of magma intrusion just above, and just below you get that alteration. And again, it's a zone of contact metamorphism. So knowing those 5 things, how sedimentary, igneous, and metamorphic rocks form, knowing that weird things happen, those are unconformities, and knowing also about this zone of contact metamorphism, knowing those 5 things, you can kind of piece together geologically the relative ages of things. So let's talk about this. From oldest to youngest, go. Give me the layers. So there are 1, 2, 3, 4, 5, A, B, C, D, E. There are 5 things going on here. Give me the sequence from oldest to youngest. Now, before you do, let me preview what's going on here. This A material almost looks like it's cutting through these layers. So what type of rock would that be? Sedimentary, metamorphic, or igneous? It almost looks like hot magma started to cut through, but then stopped, cooled, and solidified. Now, around this A material, there's all these stars which denote contact metamorphism. So therefore, this A material must have been also very, very hot. So hot material cutting through layers, sedimentary, igneous, or metamorphic. It's probably some sort of igneous intrusion. It altered these rock layers where the stars are. Those rock layers have been altered a little bit. But then you also have these horizontal layers coming through here. And another thing to think about, remember, in order for me to jump through a window, that window has to exist first. So in order for A to kind of cut through these layers, what had to exist first? Think about all that stuff. Kind of just sit here, ponder, from oldest to youngest, what's the sequence of events? Feel free to pause the video, because I'm going to stop it right here. When we come back in the next we'll do another part here of section 2. We'll kind of go over that. Let's see you back here in just a minute.